taking these areas of rotation, of spin at the surface in context with the storm is super important to be able to tell, is this a tornado? Hello everybody, welcome to the channel. My name is Rachel Center. This is Tornado Titans, weather is for everybody. I am so happy that you have joined us. Be sure to hit that subscribe button. It's right there. Subscribe, enable notifications. We do a lot of education on this channel, and I mean a lot. This is not the only educational video we've done. We've got dozens of hours of educational material on this channel. This is a place to learn about weather. This is a place to gather about weather. This is a place to watch weather, enjoy weather, and be a part of a bigger community. Weather is incredible. It should unite us all. And that's exactly why we're here today. So today's video, we're going to be talking about tornado lookalikes. We're going to be breaking down what is and isn't a tornado to hopefully just talk a little bit about this, because oftentimes people will see dust spinning underneath a storm and they will immediately assume that means tornado. It's not always the case. We're going to break it down. Let's get started. Now, I think the first thing we should do right off the top is review what is a tornado. This is very important because I think it's like, it'll help frame everything we're about to talk about. Okay, so a tornado. Oftentimes, especially when it comes to supercell, associated with the mesocyclone, there's a wall cloud, something like that, RFD wrapping around, tornado, right? So all those processes are happening in front of you. Another type of tornado that is oftentimes seen is a land spout. Vorticity stretched into the vertical, tube of dust going from the ground all the way to the sky, land spout, right? So these are two of the most common types of tornadoes you'll see. You also see like QLCS tornadoes, but I'm gonna be honest, we're not talking about that today. What we're talking about are supercells and land spouts. We're talking about supercell tornadoes and land spouts because I think this is where some of the confusion comes in.
A supercell thunderstorm, which is also tornadic, has several characteristics you should be aware of. Identifying these features as a storm becomes tornadic will help you anticipate future storm behavior. The parts of a supercell we are concerned about here include the wall cloud, the rear flank downdraft, the inflow region, and the storm's overall updraft base. In this image, you can clearly see the tornado ongoing straight ahead in the frame. To its right is the inflow region, where the storm is sucking in low-level air into the mesocyclone. The rain wrapping around the tornado, and to the left is the rear flank downdraft encircling the tornado. Above it is the storm's parent updraft base. Watch how the rain from the rear flank downdraft eventually surrounds the tornado. You should always be mindful of this occurring when near a tornado-producing supercell.
So let's talk a little bit about, like, is that a tornado? Is it a tornado? Good question. Is this a tornado or is this a tornado? Good question, right? So let's talk. Just very briefly, real talk. We need to use context clues. What's going on with the storm right now? Is this tube of dust happening under an area of rotation in the sky? Is this like rotating persistently? Is this tube of dust connected to that, or is it moving independently of that? Is the dust swirl that you're seeing, is it moving with the RFD? Is the RFD surging out and around the tornadic circulation, or the possible tornadic circulation, and causing a dust devil, basically, a gustnado? You know, these are all things that happen. Just because dust is spinning does not mean tornado. Now take a look at our first example here. You can see this tube of dust. It's right here. It's stretching up towards the updraft base right now. Is this a tornado? Well, let's use some context clues. First off, let's look at the storm itself. This is a very high-based supercell, very high-based. Could be a land spout. That would be your first tip-off, right? Well, look at the base. Is there a funnel? Is there anything rotating in the base from our vantage point? It doesn't really look like it. What I want to point you to is to this area over here on the far right, and you can see how it looks like it's kind of a shoe coming back towards this area of dust, which is now blowing from right to left. Pretty good clue. We've got us a gustnado. Now let's take a look at this next example. You can see this lowered area here on the right, a lot of rain off to the left. There's a lot of scud over here way off to the left. When you see scud like that, outflow, outflow, outflow. Oh my gosh, we've got outflow. Well, look at this area to the right. Let's zoom in on it a little bit. And you can see there is persistent rotation with this. Very persistent rotation. And it's very low hanging. And there's an area of rain to the left. The main downdraft is to the right. This is getting a little suspicious. And as you watch it, as you watch this rotation, you can see it is both persistent and increasing with time. And as we speed this up, you're gonna see this thing definitely tornadoing. How's this storm evolving? Is this storm like inflow dominant? Is everything looking tornado? Or has this storm gusted out, but there's like spinning dust, but it's obvious like outflows rushing out? In that case, probably not a tornado, probably a gustnado, right? Because there's not much inflow, not much deep mesocyclone rotation. It's probably a gustnado. Another thing to keep in mind is just like, what kind of a storm are you looking at in the first place? Like, if it's a single cell storm and there's dust underneath it, could be a land spout, certainly could be a land spout. Most likely though, that single cell storm is dropping out outflow, it's spreading in all directions, and there's gustnados happening, right? So we need to keep in mind all these possible context clues, how the storm's evolving. Now let's take a look at another example. This is a wall cloud, right? Looks very ominous. There is scud coming up. It's rushing up into this area. But let's stop for a second and let's look at this. That scud is condensing and blowing to the south. This storm was not moving south. So that's your first sign. Again, there's scud hanging out underneath this updraft now. Outflow. Feels outflowy. It's feeling outflowy. You can see the wall cloud now is lifting. This is outflowy. Look at that rain foot. We're dealing with outflow as we speak. First off, look at the spinning area right here. It's on the very corner, blowing off screen as we speak. Supercell though, we got a supercell happening. Bow lowering here, you can see the overall rotation of the storm. You can see the low clouds going from left to right. But look here, right here, blowing dust. Oh, it's spinning. It's even lifting up a little bit. There's even some motion above it. Is this a tornado? Do we have a tornado happening right now in our midst? Well, no, look at this dust. That's outflow, complete outflow. The last thing you need to keep in mind are just the features. Like, where's this happening at on the storm? Is there a wall cloud or like the area underneath the updraft with increasing persistent rotation, and then suddenly there's dust underneath that? And it's pretty clear that, you know, it's rotating up here, down here, tornado, right? Or is it happening along the surging RFD? Listen, RFDs are incredibly chaotic. There's a ton of motion there. It's gonna look like this area of spinning dust is happening under rotation, but in reality, it's not persistent. It's very chaotic. There's a lot of motion because it's outflow. It's pushing out. Outflow is chaotic. But you need to keep in mind, like, where's this happening at on the storm? Like, what feature is it under? That's a very important thing to keep in mind. When it comes to supercells, it pays to know your storm structure. Over here on the right, the alligator mouth looking thing, that's inflow. It's moving here from right to left. This shelfy thing over here on the left side, that's your RFD gust front right there. So right here in the middle, in this area in the middle, that's the area you're looking for. And you can see some persistent rotation. There's a funnel starting to form. If you see dust underneath that, tornado. If there's dust way out here to the left, gustnado. Oftentimes, so you see people report spinning dust miles away from the area of circulation as a tornado. Now, there are instances where you can get a tornado off into Neverland. Like, it can be off here and you wouldn't, it doesn't click automatically, but it's like something like a flanking line tornado. Those happen. Or you can get something in the front flank downdraft away from like the main area of rotation. Those happen. You can also get anticyclonic tornadoes. Like, here's this, and then south of it, actually south of the RFD, here's another tornado. Those happen too. So this can get confusing. But I just know when the RFD is surging, gustnados happen underneath that all the time. It is all the time that you're gonna have gustnados happening. If you're on a line of storms, all the time there's gustnadoes. And one more time, let's reiterate, spinning dust around storms is very common. In fact, it's so common that almost every storm you encounter is going to have something like a gustnado attached to it. It's going to be a normal piece of the process. If that area of spinning dust is like very clearly along an edge of outflow, you can almost bet it's a gustnado. Just saying. Just saying. So hey, your next step on your learning journey is to check out our playlist, Storm Anatomy. Just so much on there, so many storms to look at, break down, etc. Do that right now. And hey, remember, weather is for everybody. That includes you. We'll see you next time.